Hello everyone, myself Vishnu and my topic for presentation is plasmons and plasma frequency. So in this presentation I will explain plasmons, surface plasmons, plasma frequency and then measurement, how to measure these plasmons. So what are plasmons? Plasmon is a quantum of plasma oscillation just as light, which is optical oscillation, consists of photons. The plasma oscillation consists of plasmons. Plasmons are quasi-particles since it arises from the quantization of plasma oscillations. They mostly occur in metal where we have fixed positive ion, and around these ions we have freely negatively charged electrons, and these freely electrons will oscillate around these ions. So thus plasmons are collective oscillations of these free electron gas density. So in this image we have spherical metallic nanoparticle, and when we apply the electric field the electrons will shift to one side, and when we remove the field the electron shift back to the other side and will oscillate back and forth, and the charge oscillation is known as bulk plasmons. So here is animation. This shows the bulk plasmons, and we have negative charge, and it is oscillating around positive ion with frequency omega p, which is plasmon frequency. This is plasma frequency. Now we have surface plasmons. Surface plasmons are charge oscillations at the interface of a metal and a dielectric material. If there is an electric field at the surface of a metal, the charge inside the metal will rearrange and try to screen the electric field. The electric field decays very quickly inside the metal and more slowly in the dielectric. Thus, the field restricted to the surface. The surface plasmon then propagate along the surface. The surface plasmons have a lower frequency than the bulk plasmons, and hence the surface plasmons have lower energy than the bulk plasmons. And this image shows the surface plasmons at the interface of metal and dielectric, and here is a plot between the electric field decay and the distance from the interface. So we can see that uh, electric field decays very quickly in the metal and very slowly in the dielectric. So in this image, this image shows the bulk plasmons when we apply the electric field, and we have displaced negative charge, and in this B image we have metal and dielectric interface, and we have surface plasmons, and in the C it shows the charge distribution of the charge distribution of metallic particle along the interface of the metal and dielectric. So now plasma frequency. The frequency at which electron in a metal will oscillate around the positive ion if they get out of equilibrium is called plasma frequency. It is the frequency below which light will get reflected out if we shine it on a metal. And for a free electron gas, we have the dielectric function has epsilon is equal to 1 minus omega p square divided by omega square, where omega p is the plasma frequency. If omega less than omega p, then we have epsilon negative, and this epsilon negative shows that at this frequency no light can propagate through the crystal. So now how to measure these plasmons? So most common technique for plasmons is electron energy loss spectroscopy, and we can use Raman spectroscopy also. So electron with an energy of several kilo electron volt are reflected from a metal surface, and lose energy by exciting plasmons. So there is a plot which is the result of spectroscopy, and this plot is between relative intensity and the energy loss of the electron. So here larger peak is from the bulk plasmons and the smaller peak is from surface plasmons. So here are some videos which interesting video which shows the surface plasmons and Raman spectroscopy, and second video shows the surface plasma resonance. I'm going to play these videos.
We'll talk about surface plasma.
So
For
here we
surface
have
plasmon,
a
you
light
need a
source
prism,
and
you need a laser.
a
You can
gold,
see right here
gold
there is
layer,
a
and
laser
there is
beam,
a
and on top of
dielectric
the
glass.
you see there is a
So
gold layer, and on the top
when
you see like
we
some red
shine
wavelength.
light on
That is your
the
electron
interface,
oscillation, and also
there
you
is
can see on top of the layer
some
some
energy from the
buffer
light is
is flowing
absorbed,
on. So
and
you
this
basically need
energy
two
is used
layers.
for
One
the
is your
oscillation.
buffer
So
layer
here
and
are
one
bulk
is your
plasmons.
gold layer.
So
Now how it works? Now right here you can see on top of the
what
gold
happens
layer there are some electron
when these
oscillation and
electrons
buffer is
get
flowing
some
on,
energy from
and
the
when it's
emitted
gonna
light,
pass through the prism it's gonna
they
give you
will
a
oscillate,
signal.
and the reflected
And
light
right
which
now
is
you see there are
reflected from
like
the interface loses some
round
energy, which
bit
energy
of red thing
used
is
in
attaching on top of the gold layer
oscillations
and
of
it
electron,
give you a signal.
and
When new
this
buffer is
energy
flowing on, old antibody
energy
will move
loss
away
we
and
can
it actually give
see in
you
the
another
spectrum.
signal.
And here is another video which shows the surface plasma resonance.
Okay, Dave Coulter here. I'm just going to explain the surface plasmon resonance lab, mostly for my lab notebook, but also because I think it's so kick-ass it warrants a video. What we have here is a helium neon laser. Okay, so it's centered at 632.8 nanometers. That's what's coming out of this bad boy. And then it's going to hit this hemispherical, let me put some light on it, this hemispherical prism. So hemispherical because no matter what the angle of the hemisphere is to the incident light, it's always at a normal. And so that goes through the prism, which is made of glass. And then we've got a microscope slide on the back, and that microscope slide, thin film deposited on it with a vacuum nanometers thick. Resonance, and that is a fancy way, thick pole and this mirror. And you see that some of that light's transmitted, and of course some of that light is reflected. You can see it here off the mirror. What happens when the light hits the metal is that it excites the electrons in the metal, and with the careful selection of polarization, of the color of light, of the kind of metal, of the thickness of the metal, of the geometry of the interaction between the light, glass, and metal, you get something called a surface plasmon resonance. We can see there's transmitted light effect a little more clearly, and I calculate it just means the light is going to go completely in. Bam, you see that? The electrons in the gold foil. Bam, you see that? Right there, kind of bifurcates, and it's a feature that stays there. And you can see what's happening here. I'm moving the prism back and forth. So that particular angle is constant for that particular piece of metal. So that means that I did a pretty good job coating that to a very specific thickness. You can see here that laser light reflecting. I mean, that is so
And here is some reference related to this topic, and thank you.